Good afternoon to those of you on the East Coast. Good morning to those of you on the West Coast. Thank you for joining us at NPS's 22nd Annual Acquisition Research Symposium and Innovation Summit hosted by the Acquisition Research Program at the Naval Postgraduate School. This year's theme is Creating Synergy for Informed Change, Transitioning Technology to the Warfighter. And this is the panel discussion on AI metrics, software pathways, and system sustainment. I am Joseph Pack, the Transformation Lead at the Developmental Test Evaluation and Assessment Office that is a part of USD R&E, and I will be chairing this panel. Today, I'm joined by a few different panelists. Mr. Colin Dempsey, Senior Model-Based Engineering Program Manager at Carnegie Mellon University Software Engineering Institute. Dr. Joseph Brady, Technical Advisor to the Columbia Program Office, PMS 397, and Mr. Nick Tran, the Defense Acquisition Principal at the MITRE Corporation. They will be going over a few different papers with you. Before we do that, I want to make certain that I also introduce somebody else that we are honored to be joined by, Dr. Arwen DeCostanza, who will be aiding in today's discussion. She's listed as the Catalyst Pathfinder and Accelerating Force Program Manager for the Armor Research Lab. Dr. DeCostanza, would you like to say a few words?
Sure. Great. Thank you so much for having me. So as mentioned, I'm from the Army Research Lab, and I lead the Army's program called Catalyst Pathfinder Accelerating Force that's focused on building the methodology and resources behind tactical innovation or bottom-up, warfighter-driven innovation that starts with the ideas identified by our warfighters and takes them to action and transition. So after the three presentations today, I'm going to provide a short discussion that really looks at themes across the different papers and asks some questions kind of broadly and really helps to focus on our discussion and leads to the questions from the audience. So excited to be here with you today. Thank you.
Thank you very much, Arwen. We will begin with some opening remarks, followed by presentations from each of our panelists, and conclude with Q&A session. Please use the Q&A box that you should see there on your screens to submit your questions for the panelists, and then we will be addressing some of those at the conclusion of the presentations, as well as some words from Dr. DeCostanza. So with that, we will go ahead and begin with our first presentation. The first one is going to be presented by Mr. Colin Dempsey, who has a paper titled Synergizing the Software Acquisition Pathway with the United Architecture Framework for Operationalization. So with that, if we could go ahead and bring up his slides, and Colin, I will pass this over to you.
Hello, everyone. Thank you for the introduction, Joseph. I'm excited to speak on this panel today about our research paper titled Synergizing the Software Acquisition Pathway with the Unified Architecture Framework, UAF, for Operationalization. So in this presentation, we'll introduce the research paper, touch on the lifecycle view for the software pathway, the UAF standard, our basis for utilizing a scenario-based approach, the identification of software pathway scenarios, the mapping effort for aligning software pathway activities and the artifacts to UAF, and then we'll provide a summary of conclusions and next steps that we're looking at. Can you please skip to the introduction slide, please? Next slide, one more. Thank you. So DoD policy and directives motivate the transformation from document-based information to structured model-based information to enable opportunities for enhanced analysis, decision-making, and collaboration between stakeholders. However, this transformation is not necessarily straightforward, and practitioners have a lot of challenges with this transition. Our research focuses on how using a scenario-based approach for analyzing model-based systems engineering for the context of the software pathway can provide a foundation for operationalization and reduce the barrier of entry for this transition for the Department of Defense software acquisition processes. The Software Engineering Institute, which I'm part of, is working to make MBSE strategies more understandable and effective by mapping the DoD's software acquisition pathway, or SWP, policy, guidance, and required information to the Unified Architecture Framework. The ultimate goal, this aims to create a consistent approach for using MBSE and better understand its benefits. The SEI's research paper was developed as part of the MB Synergy project, sponsored by the Office of the Undersecretary of Defense for Research and Engineering, And through this MB Synergy project, the SEI seeks to equip DoD with methods and tools to model MBSE processes to evaluate the value they deliver to an organization and to analyze them from a budget, schedule, risk, or personnel resource perspective. So in short, this research aims to make MBSE more accessible and effective for DoD, specifically for software pathway programs to improve their MBSE approach as part of their digital engineering strategy. On the next slide, we'll delve into the lifecycle view of the software acquisition pathway to understand its basic structure and phases. So the software pathway is part of the DoD's adaptive acquisition framework created to streamline software development and delivery using modern methods and tools. With 86 programs already using it and a March 2025 memo from SecDef on directing the DoD to adopt it as the preferred acquisition pathway, the software pathway is continuing to increase in importance. The software pathway lifecycle is separated into two primary phases, planning and execution, each containing a set of enduring tasks that all participants in the pathway implement. The planning phase contains activities for defining capability needs, developing strategies, developing roadmaps and backlogs, establishing development infrastructure, and designing architecture details that will feed into the execution phase. The execution phase contains activities to develop, test, deliver, and assess the value of the software delivered, all while actively engaging with users to ensure needs are understood and being met. Software pathway programs are not considered major defense acquisition programs and are not subject to the Joint Capabilities Integration and Development Systems, or JCIDS, requirements. While this reduces documentation and review and approval processes, there's still a required set of statutory and regulatory information required to be generated as part of the pathway. So in all, we identified about 34 documents or collections of information required to be generated by programs executing the pathway, with varying applicability based on certain attributes of the program, cost or size. The Defense Acquisition University provides templates to help formalize the information during these activities. And these are document-based templates, but our claim is that using MBSE to structure enterprise and software system information can make documentation processes more efficient and enhance analysis and decision-making. The use of models as part of the pathway for software systems is key for reducing the documentation burden and developing continuous assurance of software in a rapid development environment. So now that we have an overview of the software pathway, on the next slide, we'll introduce the Unified Architecture Framework and its role in supporting MBSE. The Unified Architecture Framework is a standard created by the Object Management Group to describe enterprise architectures. Evolving from frameworks like DODAF, MODAF, UAF is a key tool for MBSE in the DoD. UAF is organized into a domain meta model with 89 views covering capabilities, operational scenarios, data models, and standards. It provides a comprehensive way to model all aspects of an enterprise. To supplement UAF, OMG and its partners also created an enterprise architecture guide for UAF that helps architects and model developers create models that fit the UAF specification. It can be noted that the set of 89 view specifications for UAF and the required elements and relations that should be implemented as part can be overwhelming for new users of the specification. This is where the Enterprise Architecture Guide for UAF plays an important role in providing a workflow for architects and model developers for defining an enterprise architecture model in accordance with the specification. The Enterprise Architecture Guide for UAF is an excellent resource as a general approach and process for creating enterprise models. However, the general process may not always fit the context that you're existing in perfectly, or the activities needed for a specific acquisition strategy. So we also claim that targeted guidance for the various adaptive acquisition pathways would deliver significant value to DoD model architects and practitioners, and this study explores that guidance for the software acquisition pathway. In short, UAF provides a structured way to model enterprise architectures, and with the right guidance, it can be a powerful tool for the DoD. On the next slide, we'll discuss some background on SEI's scenario-based MBSE approach and the resources we developed as part of this research. So as mentioned in the introduction, the MB Synergy project sponsored by OUSD R&E aims to demonstrate the value of MBSE within the DoD. Using the SEI's architecture trade-off analysis method as guidance for analysis, the project assesses how MBSE impacts quality attributes, extending its application, ATAM's application, from analyzing software systems to also analyzing enterprise architectures. MB Synergy employs a scenario-based analysis approach to highlight MBSE's benefits. This involves creating scenarios that capture goals, processes, and quality measures, to serve multiple purposes: define an MBSE strategy, understand information flow, evaluating process efficiency, and assuring alignment with acquisition strategies. As part of this project, we developed a UAF model template and a profile to define these scenarios, facilitating their analysis and reference. This structured approach enables us to evaluate how MBSE can enhance understandability, compliance, testability, and other quality attributes in specific contexts. Building on this foundation, on the next slide, let's look at specific scenarios we identified within the software pathway where MBSE can add value. So the software pathway scenarios for MBSE were identified by reviewing activities outlined in DoD Instruction 5087 and using the DOU guidance. The assessment produced 25 scenarios highlighting key software pathway activities that we believe benefit from the application or the use of MBSE as a methodology. And we group these by software pathway phases and enduring tasks. An example scenario is a capability needs definition, which we go into detail in the paper, which involves describing the operational context and listing desired capabilities to be implemented as part of the acquisition program. Defining capability needs as a digital model early in the system development lifecycle is beneficial for several reasons. It enhances clarity and communication among stakeholders, improves decision-making by identifying potential issues early on, and provides the basis for traceability later on in the life cycle for implementation, test, and delivery. Additionally, it mitigates risk by addressing problems proactively with users and ensures alignment with business goals, leading to better outcomes and value creation. So the SEI developed a UAF model to capture all these scenarios and align them with UAF domain meta model. This model integrates the software pathway guidance and UAF specifications, providing us a platform for ongoing analysis of MBSE's value in the pathway. When fully developed, this model can be used as a reference architecture for stakeholders of the software pathway to use for understanding the mechanisms to efficiently use UAF for structuring information and performing analysis. The model also maps the scenarios to the required statutory and regulatory information, facilitating this consistent approach that we're aiming for information collection and review during the software pathway lifecycle. We believe that this structured approach enhances the understanding, efficiency, and traceability in software pathway activities, supporting a comprehensive MBSE strategy for practitioners. To illustrate this further on the next slide, we'll examine how these scenarios are mapped to UAF views. So in general, mapping UAF views to software pathway scenarios was straightforward, and I think this highlights UAF's applicability in structuring the information needs. This ultimately transforms what the software pathway has laid out right now as a document-based approach into a model-based one. For instance, the capability needs statement definition scenario involves defining operational context, capability needs, performance measures, and user needs. These information needs were translated into a set of 12 UAF views that effectively capture this information and communicate the details, and it aligns with the intent and needs of the template provided by DAU. And the paper goes into more detail on the rationale for aligning specific views to the information needs of the pathway as well. So this mapping process was repeated for each scenario, and by doing that, we started to reveal the information and interface and flow of information between scenarios. And this indicated how information is used and, matured across the software pathway lifecycle. This, I think, highlights an important aspect that I've found most interesting while performing this exercise, which is understanding the reusability of structured information across the lifecycle. For example, the high-level list of system interfaces that you might capture in a resources connectivity view in the reference architecture is the same information needed in a test strategy document, what's defined in the cost analysis requirements description, and other documentation for cybersecurity, for example. And the ability to reuse this information in an efficient manner, eliminating duplicative work, having clear traceability and better configuration management control on the information is really the power that I think MBSE brings. In future studies, I might like to try and quantify the level of reusability of this structured information across the life cycle. And the use of AI to drive even further efficiencies in structuring and querying model information is another potential area of study that could have obvious large impacts. So going to the last slide now, let's summarize our findings and discuss the steps for implementing MBSE and software pathway programs. The research presented forms the foundational basis for the consistent application of MBSE within DoD programs utilizing the software pathway, specifically through the use of UAF. The paper identifies 25 scenarios for the operationalization of UAF within the software pathways planning and execution phases. The SEI's MB Synergy approach to perform scenario analysis illuminates the value proposition of models within the software pathway context. The comprehensive mapping of UAF views to software pathway scenarios facilitates the operationalization of MBSE, enabling stakeholders to build common processes, policies, automation, and training, ultimately reducing the burden of model development and maximizing the benefit of MBSE. For software pathway programs, this study provides resources to support digital engineering strategy, enhance lifecycle information structuring, generate robust traceability, and enable informed decision-making. The SEI plans to further develop and analyze these scenarios, aiming to collaborate with active software pathway programs to demonstrate and refine the use of UAF views. That's it for me. Thank you for your time and attention. I appreciate the opportunity to present this research to you and look forward to questions and future discussions. So contact information is listed here, and for myself and my colleague Jerome, who leads the MB Synergy project. So thank you. Back to you, Joseph.
Thank you very much for that, Mr. Dempsey. The subject of actually trying to migrate what we do between architectures and then trying to merge that with what is practical is something that's absolutely near and dear to my heart. And that is something that I think we see taking place at an even deeper level in some of the stuff that Dr. Joseph Bradley has related to some product support manager type activities and how we can leverage some of these new digital capabilities for that. So with that, I would like to hand this over to Dr. Joseph Bradley so that you can present to us some of your work.
Thank you, Mr. Pack. Appreciate the introduction. I'd like to start off by thanking Naval Postgraduate School for the opportunity to present our work as we continue to experiment and innovate in sustainment for the Columbia program. Next slide, please. While you look at the agenda that we'll really go fast through, I'd like to thank my co-authors, Mr. Baker, who is the product support manager for the Columbia, under whose auspices all this work and all this innovation is being done, as well as my co-authors now, Dr. Lemarand and Drs. Salandon and Sathiraj, who they actually did the hard work that we've captured in our paper here. Next slide, please. What we're going to focus on is the Title 10 responsibilities that Mr. Baker has, which we've quoted directly, on using predictive analysis and modeling to improve operational availability, fleet availability, material availability, and the cost of the program. The Title 10 requirement, as well as DoD and Navy requirements, led to three questions, which were the genesis for a lot of this work. How does the product support manager take advantage of the rapid advances that we're seeing? Mr. Dempsey just showed us some specifics that we're seeing. How do we turn that into reality, given that his task is to deliver a sustainment system for the entire life cycle of the Columbia, and find ways to improve on availability and costs? The other is, since we're essentially going to an industry 4.0 and less of a transaction-based environment, how do we develop and sponsor that ecosystem so that we get away from siloed simulation instances into a comprehensive and cohesive system of systems of models? And then can we export our learnings to other current or future acquisition programs, which is part of why I get to present at conferences like this. This is part of an ongoing set of action research that we've been doing, and it's primarily through the lens of complex system governance that informs us on how do we grow the ecosystem going forward. We're now going to shift to look at two of the models that really are the focus of the paper as we try to exploit the modeling capability to find new opportunities to improve ASABO, ASABM, and cost per day of availability. For those of you who pay attention, those are the direct parameters out of DODI 3110.05. Next slide, please. So the first is a discrete event simulation. This is primarily developed by Dr. Lemerand. We basically have created a discrete event simulation for the entire life cycle of the Columbia submarine. We've worked with a wide variety of stakeholders across the submarine enterprise and have, where possible, tied into other elements in the ecosystem, if you will. This work was primarily done in Simlox, which is part of the Opus suite. That's a Navy standard tool, so we didn't actually have to create coding per se in this part of the model. We get out of this model, we get the parameters, for instance, how many SSBNs at sea, how many in port, and how many are actually in maintenance, which is important for the next model, which I'll discuss in 2 slides. But if you take a look at one of the things that we've used the model for, next slide, please, this is a representation. The top one is the program of record that was determined as a result of the AOA in 2011. And you can see it's a traditional SSBN life cycle with major midlife availability, 2 smaller major availabilities at about the 10 and 30-year point, with a series of refits and patrols with periodic dockings spread along the life cycle. As the design matured and the construction actually about halfway on lead platform, we started to learn more, and we actually started looking at other alternatives that could hopefully get us more availability out of the life cycle, given that we only have 12 hulls compared to the 14 that are in service today. The bottom is a leading candidate, which actually gains availability for us, as well as handles some of the modernization challenges that we'll see during the life cycle of the submarine. So the first part, this is relatively straightforward. We have a discrete event simulation for a life cycle. We've gained knowledge and alternatives out of that. But the key part for this session is that we then take the output and go to the next phase. Next slide, please. The SSBNs are home ported in Kings Bay and Bangor. They each have a repair facility that is capable of a large majority of the work. And one of Mr. Baker's responsibilities is to estimate the size of the workforce, the skills that are needed, provide the equipment for any equipment that's needed for new stuff on board the ships. And that generated a model to actually size the facility given the known maintenance that we have coming from the design. We chose to use, in this iteration, we chose to go to artificial intelligence machine learning model. We had a predecessor model. It was basically at the end of development. The AI/ML model, which we call ORCA, we tested it against the predecessor model, and it was able to size the facility. But because of the design of the model, it actually enabled us to start answering a lot more questions that had been there but were essentially unanswerable. And at this stage, we're in pretty good shape. We're relatively young in this program. I'll point out at the bottom left, that picture is some hindcast testing that we did, where we took schedule and work packages and what was the actual resources per day compared to the predicted resources per day. You'll note that the red and the blue lines are pretty close together, and that gave us a lot of hope for going forward. In fact, it was part of the decision to continue with the development. The other part that the model gives us that we didn't have capability for before is, and this is a highly notionalized schedule to the right, but for individual ship availability of schedules, which produce availabilities, we can now look ahead, given particular resource, all the way down to the shop level. So we can say so many shop 38 mechanics, so many pipe fitters. What's the expected utilization of the facility, and where will it be overloaded? And you can look out into the future so you can think about alternatives that will reduce that overload and increase your ability to respond to that ahead of time. Next slide, please. So I said this is early. We've only been at this for a little while, less than 2 years. But the first part was to develop that manpower model. But we then discovered, as I said, that we're able to do more. So one of the things it can do is it can tell us for a given selection of work, resources, and schedule, what's the likelihood of completing those activities on time, those repair activities on time. For anyone who's in the MRO business, that's really a key decision because of the disruption of what happens when you're late. And in our business, that's a big deal. So we can now estimate and have tools that allow decision makers to be able to, if you move the repair period a little bit or you change the amount of work, how can we get that done to improve the chance of it completing on time? Or what other strategies do you have to invoke and know that upfront going into it? The 3 other capabilities, which were labeled future work, and because of the time delay between the paper being done and the presentation and release of the paper for this conference, we've actually made progress on all 3 of these. And we're developing that capability. So we have the discrete event simulation model, we have the ORCA model, which is what we call the AI model, and they couple together, and they're going to be part of a larger application suite that will be used by the repair facilities that will enable better decision making. In many cases, you'll be able to, those facilities will be able to make simulations that they could not make before and be credible. But we're not done yet there. Next, please. So here's what we've accomplished so far. Additionally, besides the ones I've already discussed, because a large fraction of the Columbia does not exist today, there is no maintenance data for that equipment, but it is very similar to a predecessor class, the Virginia. So we have mined the Virginia data, and we're beginning to build synthetic data for like equipment so that we can improve the accuracy of the predictive models for the refits based on that. Now, as the ships come into service and we actually collect real data, we'll of course transition from synthetic to real data. The other part is that we built this very iteratively. We had some starting assumptions about what tools would work. We found that they, in some cases, did not. So we plan to use reinforcement learning. It turns out, no surprise really, but in the MRO environment, we have a lot of noise in the data, and reinforcement learning has been retired basically as an approach. And so that was one of our early iterations, was to move on to that. The other is a starting assumption was that refits are refits. Turns out that refits are not refits. And depending on the rough size, we're able to cluster sizes of refits. And therefore, we have basically a piecewise continuous prediction curve that reflects the different sizes as we go along. So next. So as I said, we're not done. If we take a look at the larger ecosystem, the light blue circle in there is the discrete event simulation. The green is the ORCA model, the AIML. But we've got a landscape full of models. All the way at left is the 3D product model that was used by the builder to actually design and construct the platform. As the design matured and we knew with specificity about particular equipments, that knowledge went to what's the MRAP, which is the reliability groups. That's primarily warfare centers like Corona and Newport, Rhode Island, where they have reliability models. And then the other place the data goes to is the supply system, NavSup and to DLA. And so what we're looking at is how can we extend our model boundaries to include that so that you can actually get from an end-to-end perspective from the actual hull all the way out to the operators. One of the reasons why I continually display those three parameters out to the right is because at a symposium last year, Honorable Lohman actually described this system as a way for OSD to make resource decisions. So we're looking at being able to use those gray arrows, which would be levers that would enable decision makers in order to allocate resources better amongst the different programs, in particular, being credible for our program to defend its budget. And the next slide is simply our points of contact for those who are interested, and thank you all.
All right, thank you very much for that, Dr. Bradley. Yeah, I think one of the things that we especially see in that presentation is the fact that you're not just doing, as I find myself saying in digital engineering circles, you're not just doing engineering using digital things. You're actually doing the digital engineering and stringing it all together, which is incredibly critical. And I think it's a nuance lost on a lot of individuals who are digital skeptics, we'll say. But that being said, one of the other things that will frequently hold back digital engineering and transformation and whatnot in any field is the availability of data. If data is the lifeblood of all of this, right? And that is something that as we transition over to Mr. Nick Tran's paper, which is Scaling the Use of Publicly Available Information Across the U.S. Government, we start seeing a little bit about the use of data and about the criticality of leveraging data that is available, especially that information which is publicly available. So with that, I would like to transition this over to Mr. Nick Tran for a presentation on his paper, Scaling the Use of Publicly Available Information Across the U.S. Government.
All right, thank you for the introduction. So as introduced, my name is Nick Tran. I've been with MITRE for about 3 years. Before MITRE, I was a Navy civilian for 14 years, working in the areas of contracting, program management, acquisition policy, and requirements analysis. So going to the next slide here, this is the agenda that we'll be walking through. As the name implies, this presentation is on considerations for scaling publicly and commercially available information across the U.S. government. So for those who are unfamiliar, the MITRE Corporation is a not-for-profit organization that manages federally funded research and development centers in support of the federal government. MITRE has done several years of research in this growing field to increase the government's understanding on how to apply dTEaaC, CAI to national security issues. So working with the government and industry on this area, we'll call it PAI from here on out, MITRE has identified more than 300 commercial partners, profiled 85 vendors, conducted more than 100 assessments on capabilities, and performed experiments through 60 contracts. So as it relates to the title of this panel here, I could definitely say that a DoD capability that ingests and analyzes PAI would definitely be subject to the software acquisition pathway. However, this presentation is going to focus more on the holistic implementation of PAI for usage across various agencies to include non-DoD agencies. So the next slide is going to go over an overview, the value of PAI to the government. So it is considered open source intelligence, OSINT, in the intelligence community, though traditionally provided through means like census data, government records, traditional media platforms, imagery data, such as taken by satellites and whatnot. PAI in its modern form, as it relates to this topic, is data that is being generated based on how users, consumers interact with the technology platforms, such as logging into your social media accounts, browsing websites, using the app on your phone, driving with your internet-connected car, IP addresses, being able to scrape exposed web sources and news feeds at a hyper-rapid pace, and so on. The owners of these platforms would then sell that usage, sell that data to whichever company could benefit from it. PAI, known as alternative data in the private sector, the first big users of this type of data were financial firms, such as hedge funds, who would make investment decisions with this, trying to get that edge, increasing their alpha, maximizing their trades. Shortly afterwards, commercial and consumer goods companies started using this to help shape their product development, marketing strategies, and pricing structures. As those industries realize the benefit of PAI, so does the government, especially when collected in the aggregate, with use cases ranging from dependencies on critical minerals sourced from adversarial countries to foreign influences and financial ownership in companies who are critical to U.S. supply chains. The next slide is going to go through the challenges that we saw when organizations, government agencies try to use PAI. So a lot of federal agencies have been using PAI over the past several years, including myself while I was at the U.S. Navy assessing supply chain vulnerabilities. As a matter of fact, just over the past 3 years, the government as a whole procured more than $300 million worth of PAI across 900 contracts awarded to 40 different vendors under the acquisition threshold for commercial goods and services of $7.5 million. Now, of all of that, only 18% of those awards use some sort of indefinite delivery vehicle, such as an IDIQ, BPA, or a BOA. The rest use standalone contracts, such as C-type contracts, purchase orders, or through a subcontract. So I share all of that because the problem isn't that the government is not using PAI. They are, but are they doing it in a deliberate and strategic manner that can benefit from collaboration with other agencies who are also using PAI with the same objectives, or are we just seeing silos of excellence and potentially duplicative efforts across different agencies? So as it relates to procuring PAI, this alone is an opportunity for agencies to come together, aggregate their requirements, and put together some sort of shared indefinite delivery vehicle just for the use of PAI, which I think would help achieve economies of scale through volume-based pricing while consolidating and streamlining contracting efforts, as well as to provide some sort of demand signal to industry, signaling to them to ramp up on their end and to make investments in their technologies. Procurement is just one part of it. So the next part is, how do you want your data? How do you want your PAI? Through APIs for instant access directly from the source, or having raw data delivered in the file on a recurring basis? There isn't a wrong answer. It depends on your data strategy and how you want to scale your capability and analysis. APIs are ideal for rapid scalability, as it allows your system to ingest data seamlessly across various sources. However, there could be lag time to the core system, bogging it down with all those API connections, especially when you're looking to query against several dozen, if not hundreds of entities of interest. Bulk raw files on the other bulk raw data files transfers the responsibility of data management from the vendor side to the user side. So you do need to be able to have the infrastructure to support bulk data, especially if you want to use multiple sources at once. But that said, it does allow for pre-processing or batch processing, which can reduce lag time associated with data querying across multiple entities and sources. So what's next after getting the data? You need to be able to condition it and process it for integration so it is readily available for analysis. You may have a robust portfolio of PAI sources, maybe dozens of sources, but the value is limited to the system's ability to ingest all of that for analysis in a timely manner. Imagine trying to analyze just a dozen companies over several different sources on your own manually. It's going to take a long time. And to complicate matters, those different data sources may have different names for your entities of interest for those different companies. And those names do change in real time when there are buyouts, subsidiary creations, mergers and acquisitions, further adding more manual effort to your analysis. So luckily, there are tools and capabilities out there, such as entity resolution, where companies track how entities evolve over transactions and being able to tie them to several external data sources. Other companies do offer automation tools to help speed up that analysis. We have seen tools that does reduce analysis time from months to hours when looking across several dozen entities across multiple sources. And lastly, sharing. This is the key to scalability, the ability to share data with other organizations and agencies. This is very challenging due to different authorities. These are governed by things such as the Privacy Act, executive orders on U.S. intelligence activities, differentiating policies on collecting U.S. persons information between Title 10 defense organizations and Title 50 intelligence organizations. And there are other agencies out there such as Commerce, Treasury, Homeland Security with their own authorities. Those authorities dictate what each agency is allowed to see, which drives data access limitations. For example, not being able to see data from a particular geographic region. A lot of times, agencies don't know what other agencies are allowed to see and may not fully know that a small subset of their data and their analysis may prohibit another agency from seeing that due to their authorities. These are limiting factors when it comes to sharing analysis between agencies and organizations. This is a significant challenge, especially when trying to coordinate interagency responses. So the next slide is recommendations. How do we go about tackling these challenges? Well, it takes a village of government agencies with common objectives and similar use cases around PAI to band together in the name of achieving economies of scale through enterprise-level procurements and reducing duplicative efforts across agencies with data management, data science, and analysis. Definitely when it's highly likely that you're probably trying to achieve the same thing. So this chart describes 4 recommendations we have outlined in our paper, which addresses procurement through modular contracting using a variety of vehicles to achieve flexibility and value based on your use case. The second recommendation is identifying opportunities for shared services and resources when it comes to data standards, ontologies, conditioning, processing, and querying to reduce upfront technical effort. The third recommendation is having some sort of centralized authorities library that can help facilitate and deconflict what can be shared across different agencies. And lastly, various enabling pathways, or how I would describe as how agencies can collaborate with one another to fully maximize the value of PAI across the federal government. So let's start with the first recommendation on the next slide here, modular contracting. In the paper, we do recommend a few types of vehicles based on the data needs and expertise level. As mentioned, it is important to have a portfolio of contract vehicles to maintain flexibility and agility. Not everything is one size fits all. So for example, if there's a particular domain where you're lacking expertise in, such as cyber vulnerabilities or logistics, or maybe something even technical like how to ingest multiple data sources and have the tools to analyze them, then you may want to use like a government-wide acquisition contract, IDIQ, for turnkey solutions. But if your agency, your organization has in-house knowledge, where it's pretty strong in one data domain area, and you know the type of data that you're looking for, you may want to use a blanket purchase agreement and procure the data source directly from the vendor. Similarly, on the technical side, if you know what tools you're looking for to help with your processing and automation, and if the government is going to be the lead systems integrator, a basic ordering agreement may be a good vehicle to use for those capabilities. And lastly, I would recommend the use of commercial solutions offerings and other transaction authorities to experiment with new cases and new types of data. As we all know, there is a DoD memo out there for using other transactions for procuring software. We also understand that not every federal agency has the authority to use them. This is where such an agency can work with the General Services Administration's process for commercial solutions offerings, or maybe even going through their own GUAC as an alternative. So the next recommendation on the next slide is, once you get the data, how do you process and analyze it? So as alluded before, agencies that use PAI will most likely have use cases that overlaps with other agencies. This provides an opportunity for analysts to share how to query data across different data sources, to include developing algorithms to support automation such as queries. From a backend perspective, this can include code on how to integrate data, whether it be APIs or bulk, as well as processing and conditioning. It is highly likely that all agencies will encounter these same backend items, regardless of use cases. Overall, as the use of PAI continues to grow, it would be beneficial to share these common best practices and approaches with everyone in the space, rather than having to go alone, having to go at it from scratch, saving further time and resources. This could be enabled through some sort of knowledge management tool and capability, through a community of practice. I understand that Mill Suite is going away if it hasn't gone away already, but something like that would be a huge enabler for something like this. All right, the third recommendation on the next slide here, centralized authorities library. We talked about the difficulty of sharing data with other agencies due to different authorities that dictating on what agencies are allowed to see and analyze from data type to region. At the very basic level, we do recommend some centralized capability that tracks the different authorities on using PAI and being able to tag them to agencies analysis, setting up some sort of permission setting policy. This would allow users from different authorities to see data and analysis that aligns with what they're allowed to see. I do understand that there could be some security considerations as more specific authorities could be at higher classification levels, which does add onto the challenge of trying to figure out what can be shared. This is why it's so important to have humans in the loop from agency liaisons and stewards to facilitate this. Now, the last recommendation on the next slide. As we went over the 3 recommendations, we see a central theme here: the need for interagency collaboration, aggregating and identifying common data requirements to maximize the full purchasing power of the government, creating a community of practice to share technical best practices and approaches from analysis to development, and agencies working together to understand what they're allowed to share and what they could collaborate on. There are a lot of mechanisms for agencies to work together, ranging from interagency groups that can be driven by legislation or executive orders. At a grassroots level, which is where I see many collaborative efforts begin, interagency working groups at the program office level, typically spearheaded by some sort of executive champion or advocate, which can be done without any additional resources through a memorandum of understanding, the coalition of the willing, so to speak. There are agency directives out there that could mandate a creation of collaborative groups, at least within their own department, which can then spill over to other departments, especially with an executive champion with relationships with those other departments. So let's bring this all together on the conclusion slide. That's next. I know that was a lot to go over in 15 minutes, but here's a summary of what we believe to be important when looking to scale the use of PAI across the government and working with other agencies. You're going to do it collaboratively. Number 1, finding an organization to manage contracts. As we know, there are organizations that do specialize in providing centralized contracting services for various agencies. Also considering the recent executive order on having the General Services Administration to be the point organization for procuring common goods and services, the area of PAI could be a good opportunity for that. Second, workforce expertise, just like any other project team, having the right people with the right skill sets are important to making sure this all goes smooth. And as we just went over in the last slide, interagency collaboration. We went over this, but to iterate, scaling is not possible without this, as the name implies. Now, we believe that the most impactful opportunity with interagency collaboration is having them come together to recommend modernization of PAI policies to better enable collaboration and data sharing to support whole government responses. So that does conclude my presentation. I know that was a lot to cover, and apologies if I couldn't get any deeper into the topics as we discussed. So for more information, please read the paper, and our contact information is on the slide here, ntd-list@miter.org. Thank you.
Thank you for that, Nick. That is certainly I would think a in vogue subject, given the tremendous demand for public information, just with everything, popping up with trying to get public data sets for like AI training and things like that. At this point in time, we're going to open up the panel for any questions. There were a couple of questions that were asked, and we will they were answered inside the Q&A. We may discuss a couple of those, but I do have a couple of questions in general for the group, and I'm sure that Dr. DeCostanza will also have some questions as well. So with that, one of the things I wanted to start out with was at least talking about some of the stuff, Colin, that you had brought up in your discussion. You had talked about trying to leverage the UAF framework in order to, basically get the software pathway, which ironically is all about using software and trying to get them to not do things, I would presume, in a document-based way. So with that being said, anytime we start trying to leverage these frameworks and trying to figure out how we can address those transformation concerns, sometimes there is a little bit of confusion between whether there is a good way of doing it or whether there is the good way of doing it. So I was kind of curious, in your research, have you determined that there is that there is such a thing as a best way of modeling something like the software pathway, or at what point in time does the application play into the equation?
I think you need to consider the context that you're looking at and what issues and problems that you're trying to solve. So in this particular instance, we're looking at acquisition issues and enterprise issues that go beyond the use of something like SysML, like defining system architectures. So in this case, UAF is a more appropriate tool in the toolbox for what problems that we're trying to solve. So I think essentially you need to analyze what your context is. And this, you also have to realize, like, models can take on a lot of different forms, and it can be sometimes a confusing term. So in this context, the problem is transforming document-based engineering into model-based engineering. So in order to do that, we need to use a descriptive modeling tool versus like using CAD models or modeling. Those are obviously different types of tools for different types of problems. So in this case, we know we have a descriptive problem, so we need to use a descriptive language. And isolating which language to use, which is best, is again part of understanding what context that you need, what you're trying to solve. So in this case, there are enterprise issues, process flows, larger information than just engineering design. So we need to use a language that's been identified to solve and illuminate those problems and issues.
Absolutely. No, I appreciate that. And yeah, it's, I will say, as somebody who has about a decade and a half of architecture under my belt, I know that is one of those things that is highly frustrating to me whenever, you have people are always in pursuit of this silver bullet that's going to fix all of their problems. But you're absolutely right that the application becomes a very critical part of that. Based on application, I'm thinking about something that Dr. Bradley was getting into. Towards the very end, Joseph, at your of your presentation, you showed how a lot of the different tools and sims and everything were all connected together. And which I thought was interesting. It goes to the point I was raising about the difference between doing engineering using digital things versus actually doing digital engineering. But I'm curious, are there any kind of tools like such as like a UAF type of framework or UAFML, anything like that you have used in order to like digitally do the integration between these tools, or using something else? What can you give us some insights into that?
So in this part of the industry, the MRO industry, basically what you have is technical data, and it's a wide variety of different formats, types, unstructured, structured, that sort of stuff. So there are actually a wide variety of commercial applications, and I won't get into names here, that enable you to move that. Some of those arrows that I have on my picture should be dashed because they don't exist yet. And that's actually part of our project, is to turn them into solid lines. And so we'll be looking at how do you do that. But that's what you end up doing is it's the transport part of extract, transport, load, ETL, for those who are familiar with that term. And so that's what you're looking at. And when you try to connect those, we were, I would say we weren't lucky, but we had some knowledge. We connected a discrete event to an AIML we designed the AAML after the discrete event so that it would work together, so that we could get valid answers coming out, because we had a question from Ms. Jolliffe on that I've answered. But in general, that's not a sure thing. In fact, there was a talk yesterday about composability. And at its heart, when you look at connecting all those different models together, you have a challenge that while you might be able to connect them together, you might not get an answer at the end that's really a real answer. It's a number, but it might not mean anything. So we actually are going to do some research this summer at Arliss on the composability issue for this ecosystem, and then we'll probably continue that forward. But commercially, you use an application to move the data that way. In our case, because they're right now just 2 science projects, we haven't gotten to an application yet. It's a export of an Excel file to an import of an Excel file. In the future, we want this to be seamless and the data to be passed seamlessly over.
Roger, that makes a lot of sense. And you said the magical words. You said AI, right? So that being said, we say AI. I know that there was a just to ask a question of Nick. Dr. Bradley has answered a question in the Q&A chat, regarding verifying AI. But when you talk about AI, and I know, for any of those individuals that are AI savants, I realize generative AI is not equal to all of AI. I'm aware of this, but Nick, you were talking about the use of publicly available data, and at least when we talk about that, the one thing that's just constantly in the public zeitgeist is the use of that publicly available data to inform things that AI are working on, large language models, other generative AI and whatnot. And I was kind of curious as you were talking, you're obviously talking about scaling AI, but do you have any kind of insights into what are the things that are actually contributing to a need to be able to scale the use of publicly available data? I mean, is it really just as simple as everybody got excited about AI? And then also, I mean, what kind of problems did that really create that a lot of these scaling recommendations that you mentioned are trying to address?
Yeah. So I think probably one of the biggest one of the biggest issues. Well, let me talk about some of the most common problems that I see is in an attempt to quote unquote scale. Everyone just wants to buy everything as much as they can, but even though they're thinking they're buying everything in the attempt of scaling, that I have everything readily available, okay, let's go. A lot of times they don't even know what they're looking for in this massive ocean of data, right? And to go further at that point, I would say a lot of these data sources are out there, especially the ones that are related in a particular domain. I would say from what we've seen, 70 to 80% of them do overlap. Okay, so how do you find those things that don't overlap and then be able to exploit that? And a lot of people don't really take the time to doing that. And that's where it's so important to have a really strong data ontology to know that what are your use cases and how does that use case map to a particular data source that could be unique compared to other data sources. And that's where we get into the ability to share that. And that's probably the key thing to scaling is sharing those type of ontologies, knowing what, hey, this use case is better aligned to this data source, and et cetera. So I think it's really, and from that point on, that can help then inform AI frameworks so they know exactly because AI is typically following a workflow, right? It's I'm going to go here to pull this one, and from there I'm going to go pull to that one. So I think to do this is really having users to take the time and just compare data sources to know what makes each data source unique, rather than just from what we're seeing, people are just buying in multiple data sources just because they think that's what scaling is. Does that answer your question? Hello?
Yes, it does answer the question. I appreciate it. And, especially, it's when you start throwing in all of the other digital capabilities that we're trying to implement across the entire DoD. I mean, once again, data is the lifeblood of all of that. And as it's kind of infamously said one time, pretty much everything you need to know, 98% of it is just sitting out there publicly available on the internet, right? So, I absolutely can see how how the demand would exponentially go up. So what I would like to do at this point in time, so once again, we've had a couple of questions. I think these questions were directed at individuals who responded to them, but Dr. DeCostanza had some specific thoughts from her background working with the Army Research Lab and DEVCOM and whatnot. So Arwen, would you like to share some of your thoughts on some of the subjects of our discussion?
Yes, that would be great. So good afternoon, everyone. It's really a pleasure to be here to participate in this symposium as the discussant. And I hope that I can do all the presenters justice and, kind of trying to pull these broader themes out and really talk about them. As I do that, there is the question and answer button in there for all of the audience. So if you have additional thoughts or additional questions that you want to hear from these presenters on, I'm not going to take 15 minutes here. I'm going to take about 5. I'm going to pose some broader questions. We can talk about them, or we can answer your specific questions or your broad questions as well. So make sure you're putting those in. But since the focus of the conference is really transitioning technologies to the warfighter, and that's what I do, focus on in my job. So I really wanted to pull that thread. And then also, in light of the many changes that we're facing within the Department of Defense for consolidation of resources and efficiencies, I really wanted to focus the discussion and conclusion of this panel to look at how these bodies of work can directly impact the future of the military and our warfighters, and talk about that a bit. So we've heard from 3 very insightful papers, each tackling different aspects of how data can be leveraged for system or process improvements, and really demonstrating this growing importance of the digital transformation, data-driven decision-making within the Department of Defense, right? And these 3 papers, while focused on pretty different aspects of defense acquisition, sustainment, these different perspectives on this, they really share important connections with the impact to the Department of Defense. So from my perspective, all 3 papers highlight the importance of data-driven decision-making, whether it's structuring the software development, predicting the maintenance needs, coordinating data acquisition. The core of these papers is really on leveraging data for better outcomes for the military, right? And then all 3 papers also address the need to improve the efficiencies and reduce costs to the Department of Defense. So from streamlining software development to optimizing maintenance, avoiding redundant data purchases, I really saw this, theme of efforts contributing to more efficient resource allocation. And then a critical takeaway that I had from the presentations is that each are demonstrating quite differently how focusing on this data-driven decision-making, systems thinking, and interagency collaboration, how we can create a more efficient, effective, and responsive defense enterprise going forward. So from that, I'd like to quickly move into some discussion points and potential questions that we could revisit right after I finish talking, if there aren't others from the audience. So based on what I read in the papers and heard today, along with my experience working accelerated transition in the Army, where we're really focused on accelerating those technologies into the hands of warfighters, I'm eager to explore like 4 different areas in these papers, and maybe these are things to ponder on our drive home or wherever we're going tonight. And maybe we have time to hear from each of you on some of these, what you think is most important here. But first of all, the theme of systems thinking and integration is evident. Integrated models and software, building predictive ecosystems for sustainment, and then this centralized approach to data acquisition across these agencies. So the first thing I think is important to consider is really this like interoperability and standards. How can we take from the discussions today, or what can we take from them to ensure that data-driven models can seamlessly interoperate across the models, across programs, across agencies? What implications do these have for our standards that we can implement in our own work as we go forward? And then how can we work together to avoid creating new stovepipes as we are, in this digital realm? And I think there were a lot of implications in each of your presentations today for that. The second area is really just, it's related, but overcoming these organizational silos. Another theme in these papers and any data-driven or data-focused efforts in general really relates to challenges in organizational silos. And when you work in the Department of Defense, our organizations are vast, our silos are complex, it's a complex organization to work in. So how can we break down the silos to facilitate better data sharing and collaboration? What incentives and policies are needed to encourage a more enterprise wide approach to data and modeling from each of your perspectives? Third, I lead a program, an Army program focused on innovation, and for us in this program, one of what we talk about for the key to innovation is not just ideas, but action, adoption, and change that's really focused on the impact for improvements. And so each of these papers were kind of proposing different innovative approaches, but all of that innovation and change has secondary implications and risks. So I was curious your thoughts on how do we balance the need for these, what you're talking about, the innovations with the inherent risks associated with adopting new technologies and processes. What frameworks can the Department of Defense really use to assess and manage these risks effectively as we go, forward, with these. And then finally, and I'll stop talking after this, the impact to the warfighter. So, the underlying goal of better software, better maintenance, better data, it's to ultimately improve the capabilities and effectiveness of the warfighters that we support. So what direct implications do you think these efforts have on our nation's warfighters, and what are the most critical elements we need to focus on for this impact? And so, to me, that's the crux of what we should be talking about. I'd like to open the floor for final comments from the presenters to discuss their thoughts on these broader takeaways. You can kind of pick and choose from the 4 areas if you'd like, but I'm particularly interested in hearing your perspectives on how we can best create that truly synergistic approaches that benefit the warfighter as quickly as possible. How do we accelerate that transition in relation to your focused efforts?
Sure, I'll go ahead and start. So from your takeaways, I really resonated, and I think my paper resonated with the aspect or takeaway on organizational silos and data interoperability. Because in my experience, in my career, I've noticed that a lot of model-based systems engineering approaches have been developed maybe like from a bottoms-up perspective, where individual program offices or individual projects within those projects develop their own way of deploying MBSE and utilizing it and structuring their lifecycle information. And I think that drives inefficiencies in the way that we acquire data and can use it from a top level perspective. So that's why our take in the paper is to look at it from the acquisition level and look down and say, what information do we need to collect and capture and communicate throughout a generic acquisition process? Yeah, there are going to be some specific nuances or differences and variations of how that information is sort of communicated or viewed within the model. But starting from a common place, I think, is something that we can do better. And that was sort of the genesis of the paper's perspective. So. Over.
Yeah, thank you so much for that. And it's kind of an interesting intersection between the top down and bottom up, as you said, because the bottom up allows for that probably more flexibility, faster agility, but you're kind of missing the impact to this broader organization. And so, like, how do we adapt and move fast, but get the things that we need from the top down perspective is really critical for us to address within the Department of Defense.
Absolutely.
Anyone else?
Yeah, this is Nick here. I'll address 2 of your points here. I'll address standardization as well as value to the warfighter here. So I think when it comes to data standardization, especially with the use of PAI, when you have all those different data sources, I think we need to be really careful with how the government dictates standards. I mean, I think earlier this decade, we saw the federal data strategy, and one of their efforts was trying to come up with some sort of standards across the federal government. And I think that effort ran out of steam because it's really hard to do. And I think that, especially in our area of PAI, a lot of these companies that provide PAI, like a lot of them are non-traditionals. They're, like I mentioned earlier, that they're servicing financial firms, commercial firms right now. The government ends up being like the second, third, fourth order business right there. So, I mean, in this case, it's like really, we have to be really careful, try to dictate some sort of standards, as opposed to leaning into what is commercially available out there that's commercially being used, which is why we made the recommendation of like maybe, having on the back end among the government community of best practices, having that repository of like, these are the tools, these are the these are the algorithms, these are the development codes you want to use when trying to ingest these type of data sources into your system. So it's trying to balance, that's our approach to balancing what is commercially available and how to leverage commercially available technologies to also include interfaces that they do expose, to having some sort of like communal best practice to try to minimize duplicative efforts. Then the part about the Warfighter is the key with scalability and automation of data. We did mention a couple of use cases about going from vulnerabilities, and there are also very tactical use cases with PAI where information does need to get turned over really rapidly. So hence the automation to the use of AI is very important, but that requires really strong ontology. So people know, the machine knows how to search for the data with appropriate workflows, maximizing the value from any given data source that we have in the portfolio. Over.
Thank you. Dr. Bradley?
Yes, if I can, because we have such limited time, I'll really only address the impact to the warfighter. So part of the thrust is which I focused on, was the ability to discover combinations that might lower the probability to finish on time. One of the reasons why that matters to me is in a past life, I was responsible for all submarine maintenance in the Pacific Fleet. Turns out that every day a submarine is late coming out generates about 5 days of impact on the operating forces. So it's a really easy math calculation at that point to recognize that if you can invest a small amount of dollars relatively on making those availabilities finish on time, you have a tremendous reduction in the disruption out in the operating forces, and you are giving the COCOM or the local commander who's ever got control of the force a lot more flexibility and reliability when you do that, by making the lateness disappear, basically.
Thank you so much. I'm going to turn it back over to Joseph Pack and to conclude this, but I really appreciated your perspectives. I wish we had more time to talk, but thank you for including me in this discussion, and thank you to the audience for your questions as well. So.
Absolutely, well put, and thank you to you as well as Dr. DeCostanza, as well as our panelists, Joseph, Nick, and Colin. I really appreciate your contributions in this area. This is obviously a hot moving area, as well as many of the things that have been a part of this particular MPS workshop. But in particular, when it comes to AI transformation, all that, I mean, it's stuff where we're hitting the point where people are tired of hearing about it and they want to actually see it. And I think that one of the things that we talked about today was absolutely what some of the different efforts that are being taken place to actually see it. And we know that there's more challenges ahead of us. So with that being said, I agree with you. I wish that we had hours to talk about this, but unfortunately we don't. So with that being said, I will go ahead and conclude this session. Please, for all the attendees, refer to the symposium program for a link to the next scheduled event. I would like to thank you for attending, and given that this is MPS, I hope that you all have a beautiful Navy day.